Hey guys, welcome to Concept and Coding, and this is Shrayansh, and today I'm going to cover a very important topic, distributed messaging queue like Kafka and RabbitMQ, which these two are the most popular messaging queues. So the topics which I'm going to cover are too much in depth. I would say that from the interview perspective, right? So first thing is very basic. What is messaging queue, why it is needed and its advantages. Now you should be able to understand because the interviewer can come up with so many follow-up questions like what is the difference between pub sub and point-to-point messaging queue, right? And I will tell you the working of the messaging queue definitely, and both Kafka and RabbitMQ. But the follow-up question which should be ready is like, what if queue size limit reach? What if queue goes down? What will happen to the message which are inside a particular queue? What if the consumer goes down? What if consumer not able to process the message? How the retry will work? How the distributed messaging queue works, because you know that in the world of microservices, there are so many machines, and also how distributed messaging queue works, which is very important. Right? So if you have doubt in any of the points, I would highly recommend to go through this video because interviewer can catch you in any one of the point. Right? And with this point, with this topic in high level design roadmap, I am making this topic as right? So we'll cover this today. Okay, so let's move ahead with our first point. What is messaging queue? Why it is needed? So what is messaging queue? Messaging queue is very simple. As we all know, we have producer which produces a message. This message goes inside a particular queue, and from that queue consumer reads it and process the message. So everybody knows this message queue, how this is. Like we have a producer, we have a consumer, and we have a queue which stores the message, right? But now the question is why it is needed and what the advantage does it bring. So let's say first use case, which is also you can say that an advantage is asynchronous nature. So for example, I am taking a producer as, so let's say my producer is certain e-commerce application where user is buying a particular product, After, as soon as he buy it, we need to send a notification. But user don't have to actually wait for that notification. It can be done asynchronously. So what it can do is it can send a message in a queue that, okay, send notification. This is a message. Send notification to this user. Now we have one consumer. Let's say our consumer is send notification application. So this is our consumer. It will consume this and it will send a message, send a mail or message, anything to the user. So this can be done in asynchronous. So one thing is our latency got reduced. So just understand that if e-commerce application directly talks to send notification application, hey, can you send it? Right? So there are couple of disadvantages of that. First thing is, okay, if it goes in a synchronous manner, okay, then definitely the latency will increase because send notification, mail and this are very heavy tasks. So definitely latency will increase. But now you can say that, hey, why I need a queue? Why can't e-commerce application send asynchronous here itself? Why we need a queue? So another advantage which queue brings is retry capability. Let's say if this message sending got failed. Let's say their server is down. This is down, right? Because of some issue, this send notification application is down. So it will not be able to process anything. So what we can do is we can retry in the queue, we can put it back. So retry capability is added. Okay. So you got it. Asynchronous nature with retry capability is one use case. Second point is the pace matching. Now the same example I will use. Let's say this is my e-commerce application, right? There is another application, I would say that inventory management application. There could be another application XYZ. they all want to send a message, all want to send a notification, let's say mail. And I have one application, let's say send notification application. Now they all will call to this one. Now when they all will call to this one, right, now all they will call to send notification. But see, if they are sending 10 messages per second, if they are sending 20 messages per second, if they are sending 30 messages per second, and it can only process 15 messages per second. So definitely if you see, these producers are producing a message at a very faster pace which consumer can consume, right? So this is another issue which message queue help us to tackle. How you all three put a message into a message queue. Put your messages into the message queue, right? And subscriber, the consumer will consume it from in its own pace, right? So this is what I tell is pace matching. Through queue in the mid, you can do a pace matching, right? And let me tell you one more use case, like this will also help you understand why the message queue is very much popular. So here if you see that there is a cab, right? So in your city you have, let's say, a cab service provider, those who have so many cabs, right? They all have GPS installed. GPS installed. So now let's say everybody is sending their location every 10 seconds. 10 seconds they are sending a location. Hey, this is my car ID and this is my current location. Right? They are sending this message, all the cars. So now you can assume that the amount of data message is coming. Every 10 seconds each car in a city is sending what is the car ID and what is the current location, right? And let's say we have a consumer application which uses this, which need this data to create a dashboard like, okay, this is like, these are the cars location, right? So this consumer application cannot consume this much data so frequently, and that's why it need a queue. So this is the same thing, the pace matching, but I told you about from a different use case, right? Okay. So now you know that why it is needed and its advantage, because these are all its advantage also. Now let's move to the second point. What is point-to-point and pub/sub messaging type, right? So now let's say that what is point-to-point and pub/sub? What is the difference? So here I told you we have a publisher. Publisher, what does it do? Publisher publishes a message in a queue. So this is my message. And from a queue there can be multiple consumers. Consumer 1, consumer 2. So in a point-to-point, right, whenever the message comes in, this is message A, this message can only be consumed via one consumer, right? So let's say if consumer 1 is processing this, it will not be available for consumer 2, right? If consumer 2 is processing it, it will not be available to consumer 1. So my point is, whenever a particular message is put in a message queue, right, in a point-to-point messaging service, only it will be consumed or processed only once. It can be processed by either consumer, but only once. But in pub/sub, what will happen is, so pub/sub architecture is kind of like this. You have a publisher, right? And you have, let's say this is Q1, this is Q2, right? And you have one consumer is consuming to this queue, another consumer is consuming to this queue. So here in the pub/sub, what happens is, whenever a message comes in, right, based upon the logic, it put a message, it broadcasts the message to all the queues, right? Based upon the message, I will tell you like what are the logic. So generally here it is called as exchange. Based upon the exchange logic, it broadcasts the message to all the queues. So what happened in the pub/sub is, let's say a message comes, message A. So it broadcasts the message to all the queues. Hey, message A is there, message A is there. Now this is also consuming message A, this is also consuming message A. So in PubSub architecture, a same message can be processed by multiple consumers, and in point to point, the design should be such that a single message should only be consumed by a single consumer, right? So depending upon your business need, you have to pick one, like, okay, how you want it to design, point to point or PubSub. Okay, got it? So I think this should be clear. Now let's go to the major part, how messaging queue works. Let me tell you first Kafka, and then I will tell you the RabbitMQ. Right? They are very similar. Right? Few difference I'll tell you. So let's say that how messaging queue works. So let's first understand the very popular Kafka, and very important from the interview perspective. Before jumping into the Kafka, I'll tell you what are all the components involved. As we know, producer. Second is consumer. Third is consumer group. Fourth is topic. Fifth is partition. Sixth is offset. Seventh is broker. Then we have cluster. Then we have zookeeper. Okay, so Kafka has so many components. Now you will say that, hey, why, what we have till now covered is publisher, consumer and queue. Why Kafka has so many things? Don't worry, it's very simple. I'll tell you. Let's first see its architecture, how it looks like, and then you will see. So here we have a producer or publisher. Just say anything, right? So we have a producer or publisher, right? Now, then we have a broker. So publisher talks with broker. Now what is broker? Broker is nothing but a Kafka server. You can also say that it's a Kafka server. Whenever you start a Kafka server, it is known as one particular broker. Okay. Now what this broker has? So you know that broker is nothing but a server, Kafka server. Now once you started the Kafka, a broker is created. Now this broker, what does it has? Broker has topic. Broker has, let's say, topic. It has topic. Let's say give it a name. Every topic also has a name. Let's say it's a topic A, right? A broker can have many such topics. So it can have many such topics, topic XYZ. Let's now concentrate on a particular topic, right? Now what does inside a topic will have, right? So inside a particular topic, we have partition. It can have many partitions. So that's every partition has a name. So it has partition, let's say 0, partition 1, partition 2, partition, any partition it can have based upon the business need. Let's say it has partition 1. I have created only 2 partition, but partition can be many, right? So inside a topic, we have a partition. Inside a partition, we have offsets, which is nothing like a queue, right? Different partition can have like a different length, right? And offset start with 0 like a queue, 0, 1, 2, 3, 4, 5, 6, 7, right? Similarly 0, 1, 2, 3, 4, 5, 6, 7. It can be different also, right? So partition has offset. Now what happen is consumer read from the partition. So you have one consumer, because the ultimate data is stored inside a partition only, right? Partition only. So consumer reads from the partition, right? Now each consumer is part of one consumer group. Each consumer is part of one consumer group, right? So consumer group can have many consumers. So let's say it's a consumer 1, there can be a consumer 2, right? Similarly, there can be many consumers. So there can be a multiple groups. Consumer group 2. Similarly, it will have consumer 1, consumer 2. Okay. Now, the consumer inside a particular group, right? They have certain, you can say that logic that they do not, the same partition, they do not, you can say that share. So let's say if a topic A has two partition 0, partition 1, right? So inside this consumer group 1, this is consumer group 2. So consumer group 1, we have two consumer. So let's say consumer 1 is using partition 0. So consumer 2 will take partition 1, right? But this is not possible. Partition 0 is also taken by consumer 2. That is not possible. Within a particular consumer group, different partitions are read by different consumer, right? But this is possible. That different consumer group 2, the consumer 1 can read this, right? And this one is read by this. So this is possible because now it's a different group. So means this consumer can still go for topic A partition 0, and this consumer 2 can go for topic A partition 1, right? But within a same consumer group, they always read different partition of a particular topic. But I will go in more deep. But first, I wanted to tell you how these different components interact with each other, right? So now you understand this. Now two things left: cluster and zookeeper. Now you know that. So now what I told you is that we have a producer. Producer talks to broker. Broker has topic. Topic has partition 0, partition 1, or they can have another topic 2, another partition, right? So in a cluster there can be, so this is broker 1, there can be many brokers like this. So this is broker 2, broker 3, broker 4, right? So this is different broker means different Kafka server running in different machine. So let's say this is in node 1 or machine 1. This is running in node 2, machine 2. This is running in node 3, some another machine. Node 4, some other machine. So a group of this is called a cluster. A group of this is called cluster, right? You got it? What is mean by cluster? And then we'll call zookeeper. What is mean by zookeeper is, so different brokers, how they will interact with each other. Then we have something called zookeeper. Zookeeper help them to interact with each other. All the brokers talk with zookeeper, and everybody knows that, okay, this partition, this topic is inside which broker. Everybody knows it. Through what? Through zookeeper. Zookeeper helps internal communication that, okay, this topic 1, this partition inside which broker. Got it? I'll tell you the zookeeper need also, like, so now at least now you know high level architecture of Kafka. Now little bit goes one step deeper. Let's say how a flow comes in, one message comes in, how it works, and how it will take care of all these things. Message sizes limit, message goes down and consumer goes down, all those things. Let's go in depth and how this message works. So now let's go design a messaging queue. Producer publish one message. Message has certain things. So this is the message format. So message has key, value, partition, topic, right? So it has these 4 things. Value is nothing but the actual message. This is your actual message, right? Key is something, you can say that it can be string or ID or anything. I told you an example of the car, right? Each car is sending their location. So you can say that car ID. Car ID is nothing but a key, right? So this is you can say that it's a mandatory. Topic is mandatory, like in which topic you want to publish the message. So topic name. So here you will put a topic name, right? So these two things are not mandatory, and I will tell you how this will work. So now any certain message comes. Now let's understand this with a particular topic. So let's say in a particular topic A, you have, I am taking an example of 3 partition for say partition 0, partition 1, partition 3. So let's say a topic A has 3 partition, and this message let's say first use case, message has passed certain ID. So message has, let's say key is my 1 2 3 4 5 6 7 certain key. It can be string also. So it compute a hash of it, right? And I told you that it knows that okay, which topic name it has to put. So topic A is topic A, right? So now after this key, it will take out, okay, after computing the hash, okay, it see that okay, which partition it points to. Based upon the key hashing, it will push the data into a particular partition. But I told you that key is not mandatory. What if this key is empty? Then it goes and look for the partition. Have you defined a specific partition itself? Hey, okay, let's look, say if key is empty, then it goes and look for, okay, have you defined a particular partition itself? Then it will check, okay, partition is defined as, let's say P1. Then it will directly put into this topic P1 itself. So it will put a message here. But I told you that this is also not a mandatory, right? So what happen if this is also empty, priority partition is also empty? Then how it will decide in which partition message will go? Then if this is empty, this is also empty, then it will follow the round robin. Whenever the message comes, so message 1 goes here, message 2 goes here, message 3 goes here, then message 4 goes here, message 5 goes here, message 6 goes here. So in a round robin fashion, it will choose the partition. Understand? So I think this one is clear, right? Right? Now I'll tell you very important part of this is offset. This offset is very much important in Kafka, and you have to understand it better. Now I told you that consumers are reading it from, this is consumers are reading it from partition. Consumer are reading it from partition. This is consumer group, right? So this is consumer group 1 and this is consumer 1. Let's say I have only one consumer, for example. This is reading from partition 0. Okay. Now, and I told you that we have a zookeeper also. Now, what does this offset tell? Offset tells that till where the consumer has read the message, right? So zookeeper keep this like, okay, this is the consumer 1, and consumer group is A. Let's say this is consumer group A. Inside this consumer group A, consumer 1 is the one. It is reading a topic. Topic is A. Partition is 0, P0. Partition is P0 till where it reads. So there is something called committed offset variable. Let's say committed offset variable is 3. So means till index 3, this is successfully read. Only index 4 and more, if there are more, these are unread. So you got it? What does committed offset means? 3 means till 3 it is properly read. Only from 4 there are unread messages are present. Right? So zookeeper keep this data for all the consumers, all the consumer group consumers. Okay. This is the consumer group. This is the consumer. It is reading for this topic, this partition, what is the committed offset. Okay. And I will tell you why this is required. Okay. So now you got it. Committed offset and why this offset is important. Now understand this first part. What let's say it has two consumers. Let me have two consumer. This is consumer 2. Consumer 2. Now understand that use case this consumer goes down. It got failed. What will happen? Because it taking the responsibility of reading the partition 0 now goes down. So what will happen is, what Kafka will do, Kafka will pick from this consumer group, from this group A, it will pick the second consumer, right? Because this consumer group has multiple consumers, so if one goes down, it pick another consumer which is free, you can say that. And what it will do is, it will check, okay, the consumer which is goes down, what is its last committed offset? It says 3. Okay, till 3 it has properly, successfully read. So now it will change it from here. So from this linking, it will create it will be process partition 0 will now process via consumer 2, and it will start reading it from 4 only, because till 3 it is properly read. So now you know why committed offset is used and why consumer groups are used. Because inside a particular consumer group, if there are more consumer and if one goes down, another consumer can come up which is free, and it will start consuming the data from where the previous one left off, right? So that is why consumer group is required. So I hope you got this, why consumer group is required. I think you know why consumer group is used. You know, like, why producers, what is the role of producer, right? You know that, okay, topic is nothing but you can say that placeholder for the partition, right? So topic is nothing but a placeholder for partition. It can have many partition. So I think you know topic now. You know partition very well, like, okay, partition is the place where actual message reside, right? So it is nothing but actual data store, where the data stores. Now you understand what is the use of offset. Okay, offset is used to keep track of, okay, what all messages are read, what all are yet to be read, right? Using committed offset variable. Now broker you understand, right? So broker is nothing but a server. Now there is one more thing I will tell you. Broker, and with the help of cluster. Understand this part. This is very, very important, which help you answering so many questions. I told you that this is a cluster. This is a cluster. You know, right? What is cluster? Cluster is a, tell me, cluster is a group of broker. Let's say it's a broker 1. It's a broker 1. Let me take an example that we have 3 brokers. Broker 2. Then we have broker 3. Let's say this cluster have 3 broker, right? And let's take another example. Let's take is we have one topic 1, and this topic has, let's say, 2 partition 0, partition 1. So how the data is stored in a brokers? Let's see this. So let's say broker 1 has topic 1 and it has its partition 0. Broker 2 has topic 1, but what partition? Partition 1. So one thing you now know that even a particular topic, inside a particular topic, even the partitions can reside into different Kafka servers, right? So see, topic one, but in different Kafka servers. So Kafka server 1, broker 1 is hosting partition 0, broker 2 is hosting partition 1, right? But now you can ask, hey Shrayansh, like how it will, what if this partition goes down, partition 0 goes down? What will happen to the message which is inside it, right? So that's where we have a replica inside that. So we have replica. So now you can say that this is a replica, topic 1, partition 0. This is the replica. Similarly, for this topic 1 replica, let's say it is hosting, its replica is here. Topic 1, partition 1. This is its replica. This is its replica. Right? This is its replica. Okay. So, those who are not replica, they are called as leader. They are called as leader. So here, inside broker 1, this partition 0 of a topic 1 here is leader, and its replica, it is also known as followers. Followers. Similarly, in the broker 2, topic 1, partition 1 is leader, and its replica is stored in broker 3, which is known as followers. So all read and write happens in through leader, right? And whenever the leader goes down, then the replica takes over and become a leader. So now you got it. The first priority is always a leader. Whenever somebody is reading from particular partition, let's say message comes, right? Hey, I want a partition 0. So it will goes to the topic 1 partition 0, always goes to the broker 1 because this is leader, right? It will not goes to the broker 2, this replica, follower 1. Once the leader is down, then only the follower will take over, right? And follower, so let's say this is my leader. This is partition 0 leader. And this is partition 0 replica, which is also known as follower. So follower always follow leader. Any new message comes in, it takes it and also add in its queue also. So that's how it keep on syncing itself from the leader. Any new message comes in, it keep on reading this leader and keep adding a message. So it's a following the leader. Okay guys, so now you got it, right? So now I think you can answer this thing. Okay, so you understand how this Kafka works. Now you know that what happened, the size, queue size limited reach. So what we will do, we will have different brokers, right? Because a particular machine has limited size. Let's say even the partition maximum what you can have in a particular machine, let's say you have one machine, what is the maximum limit is, it's whatever the limit of this machine. So how we will increase it? So we will have a multiple broker 1, broker 2. So we will increase it, right? Second is what happens to message when queue goes down. When a queue goes down, nothing will happen to the message. So when whatever the leader goes down, the follower becomes the new leader. And it is syncing with the leader, so it has all the messages. Right? What happens when consumer goes down? This is very interesting. Right? So I've already told you that when consumer goes down, another consumer take over. Another consumer takes over from the consumer group. So that, and it can start from that particular offset itself, right? So this is also done. Now another part is, can you answer this? What happens when consumer not able to process message? Now let's discuss this. Not able to process message. How, what will happen? So let's say this is a queue. This is a queue. Or let's say we are talking in terms of partition, right? So let's say this is a partition. Partition is read by consumer 1 inside a particular consumer group. Okay, inside a particular consumer group, consumer. So let's say the message one is a buggy. This is a buggy message. This is a buggy message. Something is not wrong with the message, right? Let's take this example. So now consumer one picks this message one, and it's tried to process it, right? Currently, let's say it has its committed offset is, let's say this is index. This is index, let's say 6. This is 7, 5, 4, 3, 2, 1, 0. So let's say committed offset is currently 6. Till here, it is properly done. Now 7th currently processing offset is 7. It is processing the 7th offset message, but it got fail. It got fail. This because this is a buggy message. It cannot be processed. Now what will happen is, let's say we can set, okay, every message we need to do 3 times retry. We can add this capability into the partition or topic, right? Every message I need 3 times retry, 4 times retry, 5 times retry. So what it will do is, it will not increase its commit offset, right? So again, when it will pull the data, it will, okay, 6 till 6th is done. It will again send a 7th, and it will increase its retry count. 2nd time retry, 3rd time retry. So when a particular retry limit is crossed, what it will do is, it will put into another queue. It will put into another queue, which is known as failure or dead letter queue. Okay. So let's say retry is also finished, right? So committed offset is not increased. Retry is also finished. What it will do is, it will put the message one into failure one or dead letter queue, right? And it move forward. Okay, committed offset 7. I am done. Like till 7 I am done. Now give me some new messages, right? Later on, somebody can go through this queue and read it properly. Okay, what happened to the message, improve it, and again put it back to a particular working partition. Okay, so this is how retry happens, and if a particular retry fails, and this is how it is put into a dead queue or failure queue. Now, very important thing, right? I will tell you about RabbitMQ also quickly if you are interested, right? But I will tell you that Kafka is pull based approach. RabbitMQ is push based approach. Pull based approach means, here consumer is polling. Hey, do you have any new data? Do you have any new message? Do you have any new message? Right? So Kafka is pull based approach. RabbitMQ is push based approach. Here the partition, or you can say that in RabbitMQ we call it queue. So queue pushes the message as soon as the data message comes in. Right? So remember this, RabbitMQ is push based approach, Kafka is pull based approach. Okay. So I hope you are properly clear with at least Kafka, why the producer is used, why consumer is used, what is the use of consumer group and how it helps, right? What is the use of topic, partition, offset, broker, cluster, zoom keeper, and also I hope you would be able to answer properly how retry works, different ways to retry, right? I have told you the Kafka one. I will also tell you about the how the RabbitMQ works. Distributed, you got it right, different brokers called cluster and all. Now let's go to the RabbitMQ one. I'm pretty much sure you have to watch it at least 2 times to link all these things. It's a big topic and it's a favorite topic of the interviewer. RabbitMQ is exactly same as Kafka, but minor difference. I'll tell you. Here we have producer. Producer talks with an exchange. So let's say this is something called exchange. I will tell you what exchange does. So exchange is binded with. Here we have a binding of routing key. Right? So exchange is binded with the queue. Let's say Q1. Similarly, it binded with another queue, this topic Q2. This exchange is binded, let's say, with routing key 1. Whenever the routing key 1 comes in, it moves to Q1. Whenever the routing key 2 comes in, it will move to Q2. Right? Similarly, there can be multiple exchange. Exchange 1, we can have exchange 2. Right? Similarly, it will have binding also. Let's say routing key 2 comes in, it will put to the Q2. Routing key 3 comes in, it will put to the Q3. Right? So we can have this one. And here we have consumers. Consumer 1, let's say consumer 2, consumer 3. It might be consuming this also. Right? So we can have many consumers. So this is generally the architecture of RabbitMQ. So here you need to understand about this is the exchange. Different type of exchange are available. So their fun thing is fan out. Fan out exchange. So fan out exchange means, let's say a message is coming here. Message A. Message A is coming here. So in the fan out approach, fan out exchange, what it will do is it will push the message to all the queues which are associated with this exchange. It will push message A here and also to this queue. Message A here. So fan out is simply broadcasting to all the queues which are related with this particular exchange. Then second comes is direct exchange. Direct exchange means, let's say if direct exchange means routing key is exactly matching. So this is a message. This has, let's say, key is 1. So now this exchange, direct exchange will say that, okay, routing key is 1, put into the Q1. So it should be exactly matching. So it should be exactly matching. Which one? A message key and the routing key. That's okay. If it is a message key is 1 and the routing key is 1, it has to be pushed to Q1. That is called direct exchange. Another one is called topic exchange. In topic exchange, you can use wildcard. Right? You can put that, okay, if star 1, 2, 3 something comes here. So means even if it is comes as like a India underscore 1, 2, 3 means again it will put to this queue. So we can put a binding in that way, right? If anything matches in the wildcard, using a wildcard, it bring a wildcard capability, and based on that, it push the message to a particular queue. We can define a binding key like this: star 1, 2, 3, and if it is come, let's say India underscore 1, 2, 3, right? So if it is a topic exchange, what it will do is it will consider this as a wildcard, right? If it's a direct, this is not even allowed. Wildcard is not even allowed. Okay, you got it? RabbitMQ. So now let's say the last before even going, let's say if any message consumer is not able to process here. Here we don't have any offset concept. Right? What happen is, let's say consumer 1 is reading a message 1 and it's not able to process it. Right? What it will do is it will requeue it to the back of the queue. It will put message 1 requeue again. There in the Kafka, we handle it through offset. Here, what will happen is we have the capability to requeue it back. Right? It can try multiple requeue, retry 1, retry 2, retry 3. If not, it can put into a dead queue if retry finishes off. Okay, but there is no concept of offset. And I told you that Kafka is work on push approach, not pull approach. So whenever the data is present, it will push to the consumer. Okay. So this is the RabbitMQ and Kafka, and I told you the different ways questions can come into the interview. So you should be very much aware of it. And I hope we are good with this messaging queue. Any doubt, please ping me on comment section or follow or ping me on the LinkedIn. I will definitely get back to you. So with this, we are on track, right? So we still have so many things to cover, and we have covered a lot. Yeah. Okay, cool. Thank you guys. See you soon. Bye.